a 15% error rate in our API root handlers went undetected for 3 weeks. Our APM showed 100% uptime because Next.js swallows server errors internally. The article uses at OpenTelemetry/Software Development Kit node and at OpenTelemetry/Exporter Traceall proto. Ensure these packages are compatible with your Node.js version. As of early 2025, at OpenTelemetry/Software Development Kit node requires Node.js greater or equal 14, but for Next.js 16, which uses Node.js 18+, use the latest versions, e.g., at OpenTelemetry/Software Development Kit node at 0.52x. Check the OpenTelemetry.js release notes for breaking changes when upgrading. The article mentions adding custom spans around data fetching in server components, but doesn't show a concrete example. Here's how to wrap a server component's data fetching with a custom span using traceGetTracer. OpenTelemetry backends often impose limits on span attribute values, e.g., 4096 bytes for a string attribute. When adding custom attributes like error messages or request payloads, truncate them to avoid span rejection. Use span. Set attribute error message, slice 0-2000 to stay within limits. Let's break down OpenTelemetry, monitoring, and observability in Next.js 16, how it works, and the exact mistake behind that failure. OpenTelemetry is the observability framework for capturing distributed traces, metrics, and logs from server-side code. In Next.js, it uses an instrumentation.ts file at the project root that registers the OpenTelemetry Node.js software development kit during server initialization, before any application modules are loaded. This gives you end-to-end visibility into server component renders, root handlers, and server actions. Next.js 16 loads instrumentation.ts from your project root at server startup, before the application code begins executing. This is critical. You must register the OpenTelemetry software development kit, configure exporters, and load instrumentations before any application modules are imported. If you register OTEL after a module has been loaded, that module's operations will not be instrumented. Here's the boilerplate register function. It checks for edge runtime, imports the Node software development kit and exporters, configures auto instrumentations for HTTP and PostgreSQL, and starts the software development kit. It also handles graceful shutdown on SIGTERM. Auto instrumentation packages automatically wrap library functions to create spans without code changes. They capture infrastructure-level operations like HTTP requests and database queries, but they cannot capture business-level spans like user authentication duration or payment processing. For those, you need custom spans created via traceGetTracer, start span. The power of OpenTelemetry is combining both in a single trace waterfall. This custom wrapper creates a span around any fetch call. It sets attributes like the URL and status code, marks the span as error if the response is not okay, and ensures the span ends in the finally block. This gives you visibility into external API calls that auto instrumentation alone cannot provide. The after function from Next server schedules a callback to execute after the response has been sent to the client. This is perfect for non-critical post-response work like logging, metric submission, and cache warm-up. Critically, after callbacks maintain the OpenTelemetry trace context from the parent request, so spans created inside are correctly parented. Here, after is used to log slow page renders and report metrics after the response is sent. This keeps the response fast while still capturing performance data. Next.js provides use report web vitals for capturing client-side performance metrics. To correlate these with server-side traces, you need to propagate the server trace ID to the client. Embed it in a meta tag in the HTML, then read it in the callback and include it when reporting vitals. This client component reads the trace ID from the meta tag and sends it along with the web vital metric via sendBeacon. This allows your observability platform to correlate server-side and client-side performance in a single trace. A common mistake is adding a process onUncaught handler to log errors. This is dangerous because Node.js enters an unknown state after an uncaught exception, Event loop ticks may fail, file descriptors may leak, and the process becomes unreliable. Instead, use process on unhandled rejection for promise rejections, and rely on OpenTelemetry to capture exceptions within request contexts. This shows the safe pattern: handle unhandled promise rejections, but do not add an uncaught exception handler. Let the process crash and rely on your container orchestrator or PM2 to restart it. OpenTelemetry offers several span processors. BatchSpanProcessor buffers spans in memory and exports them in batches at configurable intervals. This is the most efficient for production because it reduces the export overhead from ON to O1 per interval. For Next.js server components that create dozens of spans per request, batching is essential. Configure the BatchSpanProcessor with a 2-second export interval. This balances visibility latency with overhead. In production, spans appear in Grafana within 2-3 seconds with less than 0.3% CPU overhead. After implementing OTEL, building the right dashboard is critical. The key metric that caught our 15% error rate was filtering spans with status code equals error grouped by HTTP route. This showed that /API/search had a 15% error rate while every other route was below 1%. Never monitor error rates by HTTP response code alone. This helper records route-level metrics using OpenTelemetry's Metrics API. It creates a histogram for server duration with route and status attributes, which you can then visualize in your dashboard. Server actions in Next.js 16 are called via post requests to internal endpoints. Auto-instrumentation captures them as HTTP spans, but the span names are meaningless. You need to create a custom wrapper that starts an active span with the action's name, overwriting the generic HTTP span name. This wrapper creates a span named after the server action, sets attributes, and marks the span as error if the action fails. Use it to wrap every server action for full visibility. This is the same issue we highlighted at the start. Here's exactly why that happened. Our APM agent only monitored HTTP response codes. When a Next.js route handler threw an error, the framework caught it internally, logged it to stdout, and returned a 500 response. But our APM agent only tracked HTTP response codes and did not parse Next.js server-side logs. The errors were visible in kubectl logs, but nowhere in our monitoring dashboards. The root cause was the absence of an instrumentation.ts file at the project root, which prevented OpenTelemetry from capturing server-side errors. Adding the file with proper software development kit, initialization, and auto-instrumentation enabled visibility into previously silent errors. We implemented OpenTelemetry instrumentation via instrumentation.ts with auto-instrumentation for HTTP and database clients. We added custom error span attributes to mark failed requests and configured a Grafana alert that fired when the error rate exceeded 2% over a 5-minute window. Additionally, we fixed the underlying connection pool concurrency bug by using a proper mutex for pool acquisition. This was the root cause of our incident. We assumed that errors in server components and route handlers would be captured by our APM agent since it monitors HTTP traffic. But Next.js catches these errors internally and returns a generic error response without ever throwing an unhandled exception that the APM agent could detect. A common mistake is placing instrumentation.ts inside app or src/. Next.js only loads it from the project root. If you put it anywhere else, the register function is never called and no instrumentation is initialized. Never put user email, name, or other PII in span attributes. OpenTelemetry spans may be exported to third-party platforms. Use sanitized or hashed identifiers if you need to correlate spans to specific users. When you suspect silent errors are slipping through your monitoring, these 3 checks will reveal the gaps. Compare log-based error counts with dashboard error counts. If logs show errors but the dashboard doesn't, your OTEL pipeline is missing captures. Verify the metrics pipeline end-to-end, from span creation to exporter to collector to backend display. Let's run through some common interview questions. Design an observability strategy for Next.js 16. 4 layers. Instrumentation.ts, custom spans, client-side vitals with trace ID, collector sidecar. Why are server component errors invisible to APM? APM monitors HTTP codes. Next.js catches errors internally. OTEL captures at span level. How to correlate server traces with client vitals. Embed trace ID in meta tag. Read and use report web vitals. Include in send beacon. And a few frequently asked questions. Where to place instrumentation.ts? Project root next to next, config.js. Does OTEL work with edge runtime? No, skip with process.env next, runtime == edge. What's the difference between auto and custom spans? Auto wraps libraries, custom wraps business logic. Let's recap the key takeaways. Server component errors are invisible by default. OTEL makes them observable via span status codes. Place instrumentation.ts at project root. Use BatchSpanProcessor in production. Ready to go deeper? Up next, production checklist. Security, performance, and CI/CD for Next.js, then security in Next.js 16, CSB, taint API, and server actions security, then bundle analysis and performance optimization in Next.js 16, and custom cache handlers, RIDIs, memcached, and distributed caching. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.